Good morning, students. Today we'll discuss very important topic in periodic classification, that is periodic properties. Periodic properties of elements. What are periodic properties? The properties which changes along the group and period. The property which changes along the group and period are called periodic properties. That means the property which has a systematic trends along the group and period. Group means vertical columns and period means horizontal groups. These properties are called periodic properties. What are the periodic properties? How it changes along the group and period? Let us discuss. First periodic properties is atomic radius. That is ionic radius also you can call. Atomic radius and ionic radius. Atomic radius means it is the distance between nucleus and outermost electron. What is atomic radius? It is the distance between what? Nucleus to outermost electron. That is called atomic radius. If it is an ion, same, the distance between the nucleus and outermost electron is called also ionic radius. So this distance is called atomic radius. Atomic radius, there are different types of atomic radius. You will read in higher class. That is your covalent radius, covalent radius. Another is also that Van der Waals radius. Another is metal radius. These are three types of radius: covalent radius, Van der Waals radius, and metal radius. But we will discuss in a general. Then what is the radius? Radius means what is the atomic radius? It's the distance between nucleus and outermost electron. It has been observed that this atomic radius along the group, and this is period. Atomic radius along the group increases. Along the group increases and along the period decreases. Question is why? Along the group what happens? The new cells are added. New cells are added. That's why the size that is the distance from the nucleus increases. But along the period, no new cells are produced, but electrons added in the same cell with increasing the number of protons, resulting decreasing size. When the number of protons increases but the electron added in the same cell, then the nuclear force will be more, that's why size decreases. But in group what happens? Electron takes a new cell. New cell means we can say this is the nucleus, first cell, second cell, like this, third cell. When electron occupies the new cell, then size, this is the smaller, then this is the larger, then this is the largest, like this. Size increases. So along the group size increases and along the period size decreases. For example, suppose alkali metal. To discuss alkali metal, the order size is lithium less than sodium, less than potassium, less than rubidium, less than cesium. Then francium. What is this? As these are the alkali metals arranged from top to bottom. So lithium is the smallest size alkali metals, then francium is the largest alkali metals. Because they are in the, I have written in this way, but in the table they are placed in a top to bottom. Lithium is topmost, then sodium, potassium, then this. So size increases. If you take different groups, suppose between lithium and beryllium, lithium will be larger than beryllium. Lithium size will be larger than beryllium because here what happens, beryllium is the next group, that is from left to right. If you move from left to right, size decreases. That's a lithium is greater than which one? Beryllium. If you compare the size of alkali metal, their size is greater than alkaline earth metals. So this is group 1, this is your group 1 and this is your group 2. So group 1 is always greater in size than group 2. That's why lithium is larger than beryllium. So you remember this thing, along the group size increases and along the period size decreases. So you can compare in this the techniques. Then if you take ionic radius if you compare, ionic radius comparison, you know cation, when suppose atom when loses one electron becomes cation. Then when same atom gains one electron becomes anion. So what happens when electron is losing or when atom is losing electron, then size, that is called cation. This is called cation. And this is called anion. So cation is formed when atom loses electron. Anion is formed when atom gains electron. So what is the comparison of size? When the electron is added, size increases. Then atom, then cation. So very important comparison. Cation is smaller than neutral atom and neutral atom is smaller than anion. So among cation, anion, neutral atom, anion is the largest compared to atom and its cation. So when electron is added, size increases. When electron is lost, then size decreases. So this is a very important concept between anion and cation. This is regarding your atomic radius and ionic radius. Second periodic properties is valency. We know what is valency. Valency means combining capacity. Means how many electron is involved in the formation of bond. Bond means generally we know covalent bond or ionic bond. So number of electron, valency is generally expressed as number of electron share, gain or lose by the atom. Number of electrons share, gain or lose by the atom is equal to its valence. So in case of the periodic table, along the group generally valency remains same. Valency remaining same. But along the period, what happens? Normally, general discussion we are doing. Along the group, they have similar valency, but along the period increases. Generally increases this is remaining same. But this increasing value up to a certain group then decreases. Generally, this increases up to halogen family, then decreases. So, suppose generally the group is equal to its valency. Group 1 means valency 1, group 2 valency 2, group 3 normally valency 3. Okay, and group 13 normally valency 3. So up to group 17, so up to group 14, valence will be 4. Like this. So when the atom contain 4 electron in the outermost shell, valence will be 4. If it will be more than 4, generally normally valence will be less than, valence decreases, it will be 8 minus the group position, number of valence electron. So group 1, 2, 3 up to 4, valency equal to number of valence electron. If it will be more than 4, that is group 15, group 16, group 17 like this, then valency decreases. Normally, along the group, valency remaining same, and along the period, generally valency increases. So this is the very important, but some exceptions are there. Along the group also, valency increases. Exception you can write. What are the exceptional characters? Exception is in group valency also increases. In group valency can be increased. In the same group valency can be increased, but not in all cases. Some cases valency may be increased. Normally valency increases along the period, but along the group valency remains same. Why? Why valency remaining same in the group? Because in the group they have same number of valency electrons. In group it has same number of valency electron. In a group the valency electron is same. That's why that valency electron means valency share electrons. That's why valency remains same. But in the period the valency electron increases. That's why valency increases. So this is regarding valency. Then third property is metallic and non-metallic character. Metallic and non-metallic nature. Metallic and non-metallic nature, we know the chapter metals and non-metals, what are the properties of metals, what are the properties of non-metals, already we know. Metals are luster, non-metals are non-luster, and metals are generally highly electropositive character. Like this, so many properties of metals and non-metals. So, metallic character along the group increases, and along the period decreases. This is the very, which one? This is the metal. This is the regarding metallic nature, metallic character. But non-metallic character just opposite. Non-metallic character decreases, this is increases. Non-metallic nature. So if you study any metals, if they are in left side, that means more metallic. If they are in right side, less metallic. But if they are in left side, if you compare non-metals, non-metal character will be less. If you towards right, non-metal character is more. So metallic character increases, down the group decreases. Non-metallic character decreases and increases. So this is very important. For example, if you see lithium, sodium, potassium, they are group 1. If these are group 1 metals, if you see metallic character, lithium is least compared to sodium, compared to potassium, like this. Metallic character. Between two groups, suppose here compared to sodium and magnesium. If you see, sodium is more reactive than magnesium. That means magnesium is less metallic than sodium. If metal is more reactive means metallic character is more. If metal is more reactive, metallic character is more. Sodium catches fire, potassium catches fire in air, but lithium normally they will not easily catches fire. So from left to right, metallic character decreases, and I have written like this, but this is a group. This is the group 1. This is the group 1 and group 2. This is the group 1 and group 2. Group 1 left side, group 2 right side. Group 1 is more reactive than group 2. And these are all are in same group, top to bottom, lithium, then sodium, then potassium, like this. So potassium is more reactive than lithium. So this is very important relation between different elements compare as metallic and non-metallic nature. Then fourth point is very important, is electropositive and electronegative nature. Electropositive and electronegative nature. Electropositive and electronegative. Electropositive means tendency to lose electron is called electropositive. Tendency to gain electron is called electronegative. When atom is losing electron becomes cation. This tendency is called electropositive character. And atom when gaining electron becomes negative. This tendency is called electronegative nature. Electronegative character means tendency to gain electron. Electropositive character means tendency to lose electron. But already we have discussed, already you know the nature of metal and non-metals. Metal has higher tendency to lose electron. Non-metal has lower tendency to lose, but non-metals have higher tendency to accept. So if you compare, electropositive character means more metallic character. Electronegative character means more non-metallic character. So along the group what happens? This is the group, this is the period. So this down the group increases means metallic character increases. This is the decreases along the period. So this property increases down the group, decreases along the period means electropositive character. This is the electropositive nature. Electropositive nature. And this one, if you compare this one, electronegative character means generally tendency to gain electron. Tendency to gain electron, non-metal is higher. So as from top to bottom, non-metallic character decreases. So electronegative nature decreases. But top to left to right, non-metallic character increases means electronegative character increases. Just to remember, if you know the metallic character relation, you can write electropositive character. If you know the non-metallic character, you can tell electronegative character. More metallic, more electropositive. More non-metallic, more electronegative. So you can write this thing, very important, that is concept. More metallic, means more electropositive nature. More non-metallic means more electronegative nature. I have written in short form electronegative nature, electropositive nature. So this is the electronegative nature. Electronegative nature down the group decreases because non-metallic character decreases, and left to right non-metallic character increases, so electronegative nature also increases. So this is very important relation between electropositive and electronegative character. Suppose you compare any two elements, suppose sodium and chlorine. In between sodium and chlorine, as sodium is metallic character and chlorine is non-metallic, so sodium is more electropositive than chlorine. Electropositive nature comparison. If opposite, chlorine is greater than sodium, means which nature? Electronegative nature. Short form. That means more metallic, more electropositive. More non-metallic, more electronegative. So this is the very important relation between electropositive and metallic. Electronegative, non-metallic, both are same. So don't be confused for this one. So what are the property now discussed? Metallic character, atomic radius, then valency, metallic non-metallic character, electropositive nature, electronegative nature, then very important properties remaining is nature of oxides. Nature of oxides. This is very important for your examination. Nature of oxide. Most of time questions are asked regarding the nature of oxides. Nature of oxides, there are two types. Basic oxide. This thing is very important. Remember, basic oxide is same as equivalent to ionic. Basic oxides means ionic. Acidic oxides is equivalent to covalent. Substance are two types on the basis of nature of bond, covalent or ionic. More basic oxides, more basic character means ionic. Acidic oxide means covalent. So remember this. Basic means ionic, acidic means covalent. So that is depends upon metal and non-metal character. Remember here very important thing, metallic oxide always basic or amphoteric. Already you have read in metal non-metal chapter that some metal oxides are amphoteric. Amphoteric means both acidic and basic. Then metal oxides are basic, non-metal oxides are acidic or neutral. Is very important theory. Metallic character more means basic character more, or it may be amphoteric character. Non-metallic character means the oxide will be acidic or neutral. So if you compare this one here, suppose this is regarding metallic oxides. This is metallic oxides. This is non-metallic oxides. For example, metallic oxide Metal oxide means we will discuss regarding basic character. Basic character, metal oxide, basic nature. Basic nature. Basic nature increases along the group because metallic character increases, basic character increases, and this is decreases. If you are discussing about non-metal, then non-metallic character means acidic nature. Acidic character as non-metallic character top to bottom already we have discussed decreases. So acidic character decreases. Decreases. This is increases. So non-metallic oxides are acidic, metallic oxides are basic. Along the group, basic character increases, and along the period, basic character decreases. If you discuss regarding the acidic character of non-metallic oxides, in non-metallic oxides, most of non-metallic oxides are acidic, so acidic character decreases down the group because the non-metallic character decreases. And along the period, non-metallic character increases, acidic character increases. So this is very important relation between metallic oxides and non-metallic oxide. They are acidic character and basic character. For example, sodium oxide and aluminum oxides, let it be magnesium oxide, these two. Sodium oxide is, sodium means more metallic than magnesium. As sodium is more metallic than magnesium, this oxide is more basic than magnesium. This is basic character. Suppose you compare regarding acidic character, suppose boron oxide and aluminum oxides. They are in same group, they are in boron family, boron, aluminum, gallium, like this. Boron is at the top and aluminum is at the bottom. So the element which are top, more non-metallic character, which are below, less non-metallic character. As boron is more non-metallic than aluminum, so non-metallic character of boron is more, acidic character is more. So these are very important regarding the acidic character of oxides, whether metallic or non-metallic. Okay? Now some question we will discuss now. That here the table you see, in the table group 1, group 2, group 13, 14, 15, 16 given, and these are some elements in the table. Then what are the question? As per the question you will write the answer. Largest element in period 3. This is the third period. P3, P4, P5, third period, fourth period and fifth period. Largest element in period 3. Element size generally left to right decreases. Size of element left to right decreases. So largest element in period 3 will be left side, because left to right size decreases. So answer will be A. A is the largest. Then formula of chloride of H chloride formula. H, what is the valency of H? Here is group 15. Group 15 means valence is 3. 15 group means valence 3, because already it has 5 electrons, remaining 3 electrons required. So valency 3. As it has valency 3 and formula of chloride of H will be H valency 3. So formula will be HCl3. H is the name of element. Don't confuse H is hydrogen. No. H is one unknown element H. And what is the formula of chloride taking Cl? So HCl3, because the valency of H is 3. 15 group means normal valency is 3. Similarly, most basic oxide. Basic oxide means you have to move left side. So most basic oxide, which will produce most basic oxide? Group 1. Group 1 is more metallic than group 2. So answer will be A. A will produce most basic oxides. Then most acidic oxide. Most acidic oxide depends upon the non-metal, means towards right, which will be top, come to this side. But top to bottom acidic character decreases. So question is acidic oxide, answer will be F. F produce most acidic oxides. Then formula of A and I, taking A and I is group 1, valency 1. And I is group 16. 16 means valency 2. 16 means valency 2. And A means valency 1. So valency of I is 2, valency of A is 1. So what is the formula? A to I. As I valency is 2, because 16 group means valency 2 and group 1 means valency 1. Valency of A is 1, valency of I is 2, so the formula of taking A and I is A to I. So like this type of question, hot type of question will be asked in your examination. You carefully read the table and read the question, then accordingly you will write. Okay? Thank you.